Okay, this section 5.13 is about urban runoff. So this is about water that comes down by rainfall into cities and what happens to it because of the urbanization and because of the cities. It just so happens that a typical city block generates 5 times more runoff than a woodland area of the same size. So we need to look at that and figure out where is that water going. This graphic will show you just a little bit of that. On the left, you have natural ground cover, and then you have rain coming down. And on the right, you have kind of a city and what's happening to that rain. So in the natural ground cover area, you have 25% deep infiltration into the ground, 25% shallow and only 10% runoff, and 40% evapotranspiration from the trees. And then look on the right, you've got 75% to 100% impervious cover, which means pavement or something the water has a hard time getting through, like a concrete sidewalk. So I've only got 10% shallow infiltration and 5% deep, 55% runoff, quite a lot more, 30% evapotranspiration. In a natural system, you've got porous and varied terrain of natural landscapes like forests, like in the bottom picture there. Wetlands, grassland traps, rainwater, snowmelt allows all that water to go into the ground. So you've got really good systems of infiltration and percolation. We've used both those words very recently. And you can see in the top graphic, this rain is going in. That's the infiltration, the percolation, getting all the way to the groundwater and the water table. But if I've got impervious surfaces, which are non-porous, they prevent rain and snow melt from going in. So that's roads, parking lots, and rooftops would not allow rain to infiltrate and percolate as much as you would if you had natural surfaces. What happens here on these areas where you have an impervious surface is runoff concentrates, gathers speed as it travels through sewers. Excessive volume and power empties out into a stream from a sewer. It erodes the stream bank, it damages streamside vegetation, it wipes out aquatic habitat. It increases flooding during wet weather, but it has lower stream flows during dry weather. So these all are coming from urban runoff. And then you have pollutants that can be carried by runoff. So in the top picture here, you have a little city, and all the little yellow arrows that you see are things that are polluting that are going into the storm drain. And look at where the storm drain's going, into the James River and the Chesapeake Bay. That would be in Virginia, if any of you are familiar with that area. So I've got gasoline, pesticides, hydraulic fluids, sediments, trash, oil and gasoline, trash, and something coming from a porta potty, which might be nitrogen and phosphorus. What kind of things get into the water? Sediments, motor oil, grease, motor vehicles, grease from the motor vehicles. Pesticides, nutrients come from lawns. Pathogens come from pet waste and septic systems. Road salts, heavy metals, and thermal pollution comes from dark surfaces. So that means just that the water is heating up too much. Okay, so how do we mitigate or prevent urban runoff problems? Mitigation is something that we can do to fix this problem. Wouldn't it be cool if we had permeable pavement? What if you had pavement where water could actually get through? And you see all kinds of pictures here, and I've seen places that have done this before, where you've got some kind of concrete, but in between you've got plants, like in the bottom. Or if you've got some kind of rocks and you can see at the top, someone's putting a hose on that pavement and the water's getting right through there. So that would be really cool if we could actually have the pavement, but the water would still get through. We could plant trees and other vegetation. That would be a place to mitigate urban runoff. And so as much as we can do that in cities and places like that, then those roots would soak up water and they would prevent it from running off. And we can also build up instead of out. So if you're looking at an urban area, you could build higher or build more in a smaller piece of land than you could build out. Maybe then you wouldn't have as much pavement and you wouldn't have as much urban runoff. Here is a picture of the water cycle, the urban water cycle in the middle, and on the right towards a more sustainable urban water cycle. What if I had much better infiltration because of what I did in the city, and then I would get better water sustainability. Here's a picture that's kind of hard to see, but it's city runoff down the drain. On the left, they're doing it right. On the right, they're doing it wrong. And you can see all the things that are going into the city runoff, which is not treated, and it's going directly into streams. On the left, they're doing things like collecting their dog waste, collecting rooftop water, having gardens, all kinds of washing your car at the car wash instead of in your driveway. So there's many different solutions that you can do to prevent urban runoff. This is just a fun way to end this. There's storm drains, and people did pretty art pictures on the storm drains. So what I want you to really realize is that urban runoff can be a problem when you have a lot of water coming down in a city that's been industrialized and it's not being able to get into the ground. So think about what are the problems that go with that and what are the solutions that we can do to make it better. Thank you for listening.